Yeah,
That's
and,
so
and there's a
important.
it's a literal chain and a literal link. If you think about brain science and the biology of learning, when we get sensory data that comes in, our brain is always filtering things. The first thing that it does when we have information that's coming in, well, literally the first thing that goes to the amygdala. That's the fight or flight thing, but that's a different question. But that's a question of like classroom safety and that type of thing. But that's a different discussion. But
Right.
the information comes in and it goes through the back integrative cortex in the temporal lobe, and it tries to find connections to things that we already know. And if it does, it'll start making that a new neural pathway to link the new information with the old information. And then it gets transferred when there's a problem to be solved or a scenario to work through. That comes in, and that's in our working memory in the frontal lobe. And then the information from that back integrative cortex starts talking to the information in the front integrative cortex, and it tries to figure things out. And once it decides what you're going to do, then it moves it into the motor cortex and you actually do something about it, like physically, talk, write. But every time you trigger that cycle, because once you do something, that becomes new input, right? And the cycle keeps continuing: input, connection, analysis, motor skills. Um, every time you do that, it fires that neural pathway. And there's a substance called myelin that coats that neural pathway every time it gets fired. So if it only gets fired once, it becomes a very weak link with not a whole lot of myelin in it. But if you keep firing it over and over and over and over and over again, it gets a very solid coating of the myelin substance, like a fatty substance, over that neural pathway, and it solidifies it. So, it's
Wow.
like you can't just tell somebody to do something once, because that's a weak link and it's easily broken. But if you have them work through something, like I send them to a training event and they learn how to do something once. But if I'm not coaching to that when they get back to the workplace, then that weak link breaks. It's like a literal link, and so I need to take them back into the workplace, and I need to fire that link over and over and over, and continue to coach them through it. So there's a bigger process. We want them to want to do it. We need to expect them to do it. We need to train them, and then we need to support them as they transfer that back to the workplace.
Wow, that's amazing. I love that. And it reminds me of a couple other models and theories that we use often in instructional design and education. And I actually did a presentation recently for Connie's Mastering Instructional Design event that she does monthly. And I talked about adult learning theory, kind of gave them, a just a refresh of it. But then I
Mm.
connected the ARCS model, which is
Yep.
about attention, relevance, that
Yep.
confidence and that satisfaction, which ties really well into what you're talking about. And then also I talked about cognitive load theory and how, yep, we can motivate them and that's great. But as you were talking about the brain, we there's so much of that science behind it. And cognitive load theory
Yeah.
by Sweller is just, yeah, it
Yeah.
just fascinates me so much. All these different research, the different types of research they've done over the years. So that's fascinating too. So if we're giving the learners something over and over again, but we're giving them too much of it, it's not going to
Yeah.
stick either, right? Yeah, it's
Yeah.
just gonna go into short term memory, and then it's not going to stick in long term memory, right?
Yeah, because
Yeah,
cognitive load is real. That deals with the working memory. And that's limited. There's only so much capacity. If we overload that working memory, that frontal lobe, it can't work. It doesn't leave enough space, like literal space, because you're dealing with neural pathways. It
right.
to think through a new thing.